What if I told you that while you were scrolling through social media last month, a mysterious object from another star system was quietly racing through our solar system at impossible speeds? Meet Atlas, the third confirmed interstellar visitor that's breaking every rule we thought we knew about comets. This isn't your typical space rock, and what scientists discovered about its composition has some asking a question that would have been laughable just decades ago. Could this be artificial? In the summer of 2025, astronomers around the world turned their attention to a strange new light moving through our solar system. At first glance, it looked like a comet, but something about it stood out immediately. Officially, it was given the name 3I Atlas. The 3I stands for Third Interstellar Object, and that is the key point here. This is not just another icy rock drifting in from the outer reaches of the Kuiper Belt. This is a visitor from deep interstellar space, a wanderer that does not belong to our sun's family of planets and asteroids. To put that into perspective, we have only ever confirmed two other interstellar objects before this. The first was Oumuamua, discovered in 2017, a bizarre cigar-shaped object that defied explanation with its unusual speed and trajectory. Scientists still debate whether it was a fragment of a shattered planet, an icy body that lost its tail, or even an alien probe. The second was 2I Borisov in 2019, which looked much more like a traditional comet with a tail and predictable behavior, though it too had crossed the vast distance between stars. Now we have 3I Atlas, the third of its kind, and it is already proving to be the strangest of them all. Unlike Borisov, which behaved in a familiar way, or Oumuamua, which refused to give us a clear picture of what it was, Atlas presents us with something entirely different. It was first noticed on July 1, 2025, by NASA's Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to scan the sky for incoming threats. That's where the Atlas part of the name comes from. But later, astronomers realized that this object had actually been captured in images much earlier. On May 7th of the same year, NASA's Transiting Exoplanet Survey Satellite, or TESS, had taken a snapshot of the object while it was still between the orbits of Saturn and Jupiter. At the time, TESS was busy searching for alien planets, so the discovery went unnoticed until researchers went back through the data. That detail is important because it tells us how fast Atlas is moving. In just a matter of weeks, it traveled from the outer solar system to the orbit of Mars, a journey that would take even our fastest spacecraft over a year and a half to complete. Its speed, along with its hyperbolic trajectory, makes one thing absolutely clear. 3I Atlas does not belong here. It is simply passing through, and soon it will be gone forever. Think about that for a moment. For billions of years, this object has been wandering through the galaxy, traveling from a star system far older than our own. It has drifted in silence through the dark void between stars, and now, by sheer chance, it has crossed paths with us. We have only a narrow window of time to study it before it vanishes back into interstellar space. That makes every observation urgent, every piece of data precious. Scientists know this may be our best chance yet to study a truly alien object, and what they have already found raises more questions than answers. Once astronomers confirmed that 3I Atlas was not a local object, the next step was to calculate its orbit. And what they discovered immediately confirmed its interstellar origin. Unlike asteroids and comets that are born within our solar system, Atlas is not bound by the sun's gravity. Its path is hyperbolic, meaning it will swing in, loop around the sun once, and then continue on its way back out into deep space, never to return again. For comparison, most comets we know follow elliptical orbits. They come in close to the sun, heat up, release gas and dust, then drift back to the outer solar system before repeating the cycle. Atlas is different. Its speed is simply too great for the sun to pull it back. Even as our star exerts its immense gravitational force, Atlas will not be captured. Instead, it will slingshot past the sun, and head back into interstellar space, carrying with it the secrets of its distant origin. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. The timeline of its journey is remarkable. Back in May 2025, it was still out near the orbit of Jupiter. By September, it had already closed the distance to Mars. That is an incredible rate of travel. For context, when NASA launched the Voyager probes in the 1970s on a direct trajectory toward Jupiter, it took them nearly 2 years to make the crossing. Atlas covered that same distance in just a few months. This is why scientists can be so certain about its interstellar status. No object formed in our solar system could move this fast without help. Its closest approach to the Sun, known as perihelion, is set for October 29, 2025. On that day, Atlas will pass directly in front of the Sun from Earth's point of view, briefly hidden by its overwhelming glare. After that, it will re-emerge in December, but by then it will already be on its way out of the solar system. The window to study it is narrow, and every telescope on Earth and in orbit is being pointed at this mysterious traveler while it is still within reach. But here is what makes its speed even more fascinating. The faster it moves, the harder it is to study. Instruments have to adapt quickly to track its position as it races across the sky. In fact, the very fact that it appeared so suddenly and will disappear so soon highlights just how rare and fleeting these interstellar encounters really are. This is only the third time humanity has had the opportunity to watch an object from another star system up close, and already Atlas is proving to be the strangest yet. Astronomers know this much. It cannot stay. No matter what it is made of, no matter what secrets it holds, Atlas is only passing through. It entered our solar system on a trajectory shaped by billions of years of travel through the galaxy, and on that same trajectory, it will leave. That reality gives its visit an almost ghostly quality. For a brief moment in cosmic time, this alien object has crossed paths with us. Soon, it will vanish into the darkness once again, leaving us with only the data we were able to capture during its short stay. And that is why this hyperbolic orbit matters. It is not just a technical detail. It is the signature of an interstellar traveler, proof that 3I Atlas is not of our world, not of our Sun, but of some distant star system far older and stranger than our own. One of the first clues that 3I Atlas was no ordinary comet came from its brightness. Normally, comets are faint and difficult to detect until they drift closer to the Sun. That's because most of them are made of frozen water mixed with dust, gas, and rock. These icy bodies spend most of their lives far from the Sun, where it is too cold for anything to melt. Only when they cross inside the orbit of Jupiter does the Sun's heat become strong enough to trigger sublimation, the process where ice transforms directly into gas in the vacuum of space. It is this release of gas and dust that creates the glowing halo called the coma and the familiar tails we associate with comets. But Atlas broke those rules. When NASA's TESS satellite accidentally photographed it back on May 7, 2025, the object was still far beyond Jupiter's orbit, in a region of space where ordinary comets remain frozen and inactive. And yet, in those first images, Atlas was already shining much brighter than it should have been. Even more puzzling, over the 3-week period that TESS observed it, the brightness didn't remain constant. It grew steadily, as if the comet were already shedding material and building up its coma, something that should not have been possible so far from the Sun. This is what caught astronomers' attention. If Atlas were behaving like a normal comet, it should have remained quiet and inert until at least the asteroid belt. Instead, it was glowing as if it had been set alight too early. This raised immediate questions about what Atlas is actually made of. Perhaps it carries materials that begin to sublimate at much colder temperatures than water ice. That would explain why it appeared so active while still in the outer solar system. To make the comparison even clearer, Think about the two previous interstellar visitors. Oumuamua baffled scientists because it showed no signs of sublimation at all. No coma, no tail, nothing, despite passing close to the sun. Borisov, on the other hand, looked and acted like a textbook comet, producing water vapor and dust only once it got close enough to heat up. Atlas seems to sit at the opposite extreme from Oumuamua. Instead of showing no activity, it was active too soon, and in a way that does not fit with anything we've seen before. As the weeks went on and more telescopes were aimed at Atlas, the mystery only deepened. Its early brightness was not just a fluke, it was a consistent feature of its behavior. The object seemed to ignore the usual rules of distance and temperature, and that meant one thing: whatever Atlas is made of, it must be different from the raw materials that shaped our own solar system. For astronomers, this was exciting news. Every comet that forms around our sun carries within it a record of our system's origins: frozen water, carbon-based molecules, and the dust of long-dead stars. But Atlas, by behaving so strangely, hinted at an entirely different chemical recipe, a fingerprint from a foreign star system. By studying its unusual brightness and the materials causing it, scientists might finally get a direct sample of what planetary systems elsewhere in the galaxy are made of. So while Atlas's early glow may seem like just a curious detail, it is actually one of the most important clues we have. It tells us that this object is not just an interstellar traveler, but also a messenger from a place unlike anything we've ever known. And the more we watch it, the more alien it seems to become. If there was still any doubt that 3I Atlas is unlike anything we have seen before, it disappeared once astronomers began studying its tail. Normally, comets develop their tails in a predictable way. As sunlight heats the icy nucleus, gas and dust erupt outward, and the solar wind, a constant stream of charged particles blowing from the sun, pushes that material away. This is why comet tails always point away from the sun, no matter which direction the comet itself is traveling. It is one of the most reliable patterns in astronomy, but Atlas decided not to play by the rules. As it drew closer over July and August 2025, telescopes detected that the coma, the glowing cloud of gas surrounding the core, was beginning to stretch into a tail. At first that seemed normal, but then astronomers noticed something bizarre. The tail was not streaming away from the sun as expected. Instead, it appeared to be pointing toward the sun, as if the solar wind were somehow reversed. To understand how strange this is, imagine a dog leaning out of a car window while the vehicle speeds down the road. The rushing air pushes the dog's ears and fur backward, away from the wind. That is how comet tails behave, pushed back by the wind of particles from the sun. But in Atlas's case, it is as if the dog's fur were somehow blowing forward, stretching toward the oncoming air. It makes no sense in terms of basic physics, and yet that is what the data showed. This discovery threw scientists into confusion. Could it be an illusion caused by the angle of observation? Or was Atlas actually producing jets of gas and dust powerful enough to overcome the solar wind and push its material sunward? Both explanations seemed unlikely. If it were just perspective, the effect should have shifted as Atlas moved along its orbit. But the sunward tail persisted, and if the jets were strong enough to defy the solar wind, then Atlas must be releasing an enormous amount of energy, far beyond what any comet should be capable of. Naturally, this only fueled speculation. Was Atlas reacting to some unusual composition within its core, perhaps releasing gases we are unfamiliar with? Could magnetic fields be playing a role? Or was something even stranger at work? Some observers began whispering the word artificial, wondering if this peculiar tail might be a deliberate emission, the kind of signal you would expect from a spacecraft, not a comet. While scientists remain cautious, the strange orientation of Atlas's tail is one of the clearest signs that this object is not behaving like anything we are used to. It breaks one of the simplest, most consistent rules of cometary science. And whenever nature breaks its own rules, it means we are on the edge of discovery. This is why the world's most advanced telescopes, from Hubble to the James Webb, were quickly aimed at Atlas. Researchers wanted answers. They wanted to know what kind of object could defy the solar wind, and whether its sunward tail was a sign of unusual chemistry or of something more mysterious. If the strange tail of 3I Atlas was not enough to puzzle astronomers, what they found inside its glowing coma was even more extraordinary. Normally, when comets venture close enough to the Sun, their icy surfaces begin to vaporize. The most common substance released is water vapor, since comets are essentially dirty snowballs left over from the early solar system. Along with dust, bits of rock, and occasional traces of carbon-based molecules, water makes up the bulk of their outgassing. But when powerful instruments began analyzing the light from Atlas, they quickly realized this was no ordinary comet. Instead of water dominating its chemical signature, it was carbon dioxide, frozen CO2, making up the overwhelming majority of the gas. In fact, the ratio was astonishing: 16 parts carbon dioxide for every 1 part water vapor. To put that into perspective, most comets in our solar system show the opposite balance. Water vapor is usually by far the strongest signature, while CO2 appears only as a secondary trace. Even Oumuamua and Borisov, the two interstellar objects spotted before Atlas, did not display anything like this ratio. Atlas, it seemed, was made of something completely different. An icy body born in an environment where carbon dioxide dominated over water. This raises enormous questions. Where could such a comet have formed? For water to be so scarce and CO2 so abundant, Atlas must have been born in a region of its home star system that was extremely cold and distant. A place where carbon dioxide ice was stable, but water ice was rare or locked away. This could mean that the system Atlas came from was very different from our own, with a composition unlike anything we've studied up close before. And there's another layer of mystery. Carbon dioxide sublimates, meaning it turns directly from a solid into gas, at lower temperatures than water ice. That means Atlas could start releasing CO2 while still far from the Sun, long before water ice would normally activate. This may explain why it brightened so early, beyond Jupiter's orbit, when traditional comets would have stayed dark and frozen. But it doesn't explain the sheer quantity of gas it released, or why the coma was so enormous compared to the nucleus itself. Some scientists suggested this might mean the nucleus of Atlas is unusually porous, filled with CO2 pockets that vent spectacularly once sunlight hits them. Others wondered whether Atlas had been exposed to some catastrophic event in its past, a collision, or tidal heating near a massive planet in its original star system that restructured its chemistry. And of course, more speculative thinkers had other ideas. Could an object rich in CO2 serve as fuel? Could it be deliberately engineered to release this gas for propulsion or even terraforming purposes? While such ideas remain outside mainstream science, they highlight just how strange Atlas is compared to the comets we know. One thing is certain: the discovery of carbon dioxide dominance in Atlas was a turning point. It made astronomers realize they were not simply studying another icy traveler from beyond the stars. They were looking at something fundamentally alien in its chemistry, something that might rewrite what we know about the building blocks of other planetary systems. As astronomers measured the composition of 3I Atlas, they quickly realized the scale of its outgassing was far beyond anything they expected. The carbon dioxide wasn't just present in unusual amounts. It was forming a vast, expanding cloud around the object, a coma so large it defied comparison to most comets we've seen before. Observations revealed that the gas cloud stretched out an incredible 300,000 kilometers in radius. To grasp that size, imagine a sphere larger than the distance between the Earth and the Moon. It meant Atlas wasn't just venting, it was spewing material into space at a level that made even our largest comets seem modest. This raised a critical question. How big was the object hiding inside that glowing veil? The nucleus, the solid core of rock and ice that drives a comet's activity, could not be seen directly, cloaked as it was in its bright coma. But by studying the density and extent of the gas cloud, scientists estimated the central body might be as large as 46 kilometers across. That is staggering. For comparison, Comet Halley's nucleus is only about 11 kilometers wide. The famous Comet Hale-Bopp, one of the brightest in modern history, had a nucleus roughly 60 kilometers across. If the estimates hold true, Atlas could rival the largest known comets ever observed. And yet, it is not even from our solar system. It comes from the depths of interstellar space. The implications are enormous. A nucleus of that size, shedding carbon dioxide at such intensity, would contain vast reservoirs of frozen material. It would mean Atlas carries with it a record of conditions in its birth system, preserved across billions of years, and now drifting through our cosmic neighborhood. But there is another possibility that unsettled some researchers. What if the nucleus isn't actually that big? What if instead, Atlas is simply unusually active, expelling material at rates far beyond what we'd expect for an object of its size? That could mean the estimates of a 46-kilometer nucleus are misleading, and the true body inside might be smaller, behaving in extraordinary ways. The truth may only be revealed as Atlas moves closer to the Sun, where its activity can be tracked more precisely. But even now, the sight of such a massive CO2-dominated cloud has sparked new debates. Why is it so large? What keeps the gas flowing at such intensity? And is this sheer scale another sign that we are dealing with an object unlike anything born in our solar system? Some even took the speculation further. If Atlas were artificial, or at least engineered in some way, then a massive, bright coma could serve a purpose, like a shroud masking what lies beneath, or even a form of propulsion, dispersing gases in controlled bursts. While such theories remain on the fringe, they underline how unsettling this discovery was for many who expected Atlas to behave like a normal comet. For now, what can be said with certainty is this: 3I Atlas has the largest, most dramatic coma of any interstellar visitor we have ever studied. Its enormous CO2 cloud makes it not just another icy traveler, but one of the most spectacular and puzzling objects astronomers have ever set their sights on. As if Atlas had not already shattered enough expectations, one more discovery left scientists scratching their heads. Using the immense power of the European Southern Observatories' Very Large Telescope in Chile, astronomers probed the composition of the gases flowing out of its coma. What they found was astonishing. Spectral analysis revealed the presence of nickel, one of the heavier elements usually locked deep inside rocky material. Detecting nickel in a comet is rare but not unheard of. Astronomers have observed it in certain long-period comets within our own solar system. But in those cases, nickel almost always appears alongside iron, its chemical twin. The two elements are bound together in most natural processes. They form under similar conditions, and when one is present, the other almost always follows. But not with 3I Atlas. The data showed nickel, but no trace of iron at all. It was like finding salt without pepper, or thunder without lightning. The absence of iron made no sense. Where had it gone? How could nickel exist in isolation? This finding forced scientists to consider unusual possibilities. One idea is that Atlas formed in a region of its home star system with highly specific conditions, perhaps temperatures and chemical balances that allowed nickel to condense while iron did not. But that scenario would be extraordinary, requiring an environment unlike anything we have documented in the birthplaces of our own comets and asteroids. Another possibility is that Atlas once contained both nickel and iron, but something in its long interstellar journey altered its chemistry. Maybe cosmic rays or repeated heating cycles stripped away the iron, leaving nickel behind. But again, this explanation is hard to reconcile with what we know of metal stability in space. Of course, once again, speculation ran wild outside mainstream circles. Some suggested that the selective presence of nickel without iron might be the result of a refining process, something deliberate, like smelting. On Earth, when we separate metals for use in technology, we often end up with one material in higher purity than the other. Could Atlas be showing the fingerprint of an engineered object rather than a natural one? Most scientists remain cautious. But even the most skeptical voices agree. The nickel discovery is one of the most puzzling aspects of ATLAS so far. It is a clear chemical anomaly, one that cannot easily be explained away as a trick of light or perspective. The bigger picture is this. Every time researchers peel back a layer of ATLAS's mystery, they find something that doesn't belong, something that challenges our assumptions about how comets should behave, what they should be made of, and where they should come from. Nickel without iron is just the latest reminder that ATLAS is no ordinary wanderer. It is an object that seems determined to rewrite the rulebook of planetary science. By the time ATLAS revealed its strange behavior, the sunward tail, the carbon dioxide dominance, the vast coma, and the nickel without iron, scientists and the public alike were running out of familiar explanations. Nature seemed to be breaking its own rules, and whenever that happens, the human imagination begins to wander into extraordinary territory. And so the question was asked, quietly at first, then louder in late-night discussions and online forums, what if ATLAS isn't a comet at all? Some theorists began to speculate that this mysterious object could be an alien probe, moving deliberately through interstellar space. The unusual tail pointing toward the sun was cited as possible evidence of propulsion, gas being vented in a controlled way, like the exhaust of an engine. Others suggested that the overwhelming carbon dioxide emissions could be part of a design, a system of thrust, or even camouflage, making the object appear to be just another comet, when in fact, it is something far more advanced. Another idea was even more radical, that ATLAS could be a giant life form, a kind of organism that survives by drifting between star systems. In this view, the carbon dioxide emissions might not be exhaust or ice sublimation, but the metabolic activity of a creature unlike anything we could imagine. Its coma could be seen as a protective shell, or even as a way to interact with solar energy in a manner similar to photosynthesis. While highly speculative, such ideas reflect just how alien ATLAS's behavior appears when compared to known comets. Third camp leaned toward the concept of ATLAS as a CO2 venting spacecraft, a megastructure built by an advanced civilization, perhaps as a way of traveling between stars. To them, the nickel detection without iron was not just a chemical curiosity, but a possible signature of technological refinement. The way humans process metals for specific uses, of course, mainstream scientists remain cautious about all of these theories. The vast majority emphasize that extraordinary claims require extraordinary evidence. While ATLAS is undeniably strange, it is still more likely to be a natural object with unfamiliar chemistry and physics than an engineered craft or alien organism. History has shown that when the universe surprises us, the explanation is usually exotic but still natural. Yet, it is also true that we are living in an era where the search for extraterrestrial intelligence is no longer taboo. Missions like Breakthrough, Listen are actively scanning the skies for signals, and the possibility of interstellar artifacts has been openly debated since Oumuamua's flyby in 2017. Against that backdrop, ATLAS has become the perfect canvas for our hopes, fears, and imagination about intelligent life beyond Earth, whether a probe, a life form, or simply a comet that breaks the mold. ATLAS has forced us to confront how little we truly know about the galaxy. It reminds us that when something from beyond the stars enters our solar system, it may not fit neatly into the categories we've built from studying our own backyard. And that uncertainty, that crack in the door of the unknown, is enough to keep the alien question alive in the minds of many. For all the mystery surrounding 3I ATLAS, one of the most exciting opportunities to study it is coming very soon. In early October 2025, the object will make its closest approach to Mars, passing at a distance of about 28 million kilometers. That may sound vast, but in astronomical terms, it is a close encounter, close enough that spacecraft already orbiting Mars will have a chance to turn their cameras and instruments toward this interstellar visitor. 2. Spacecraft in particular are poised to play a key role: ESA's Mars Express and the ExoMars Trace Gas Orbiter. These missions were never designed to study comets, let alone interstellar ones. Mars Express has spent over 2 decades mapping the Martian surface and atmosphere, while ExoMars focuses on detecting trace gases that could reveal geological or biological activity on the red planet. Yet both carry cameras and spectrometers capable of capturing valuable data on Atlas. Scientists are eager for this chance because most of our current observations come from Earth-based telescopes. While powerful, those instruments are still limited by distance and atmospheric interference. A view from Mars' orbit would provide a completely new vantage point, one not filtered through Earth's skies, and one far closer to the action. Even a handful of images could reveal details about the coma's structure, the orientation of the tail, or sudden changes in brightness that might otherwise be missed. There is also the possibility of catching Atlas in transition. As it approaches perihelion at the end of October, its activity may ramp up dramatically, releasing even more carbon dioxide and potentially reshaping the coma. A Mars flyby happening just weeks before that moment is a rare stroke of timing, a chance to watch Atlas as it gears up for its closest pass to the Sun. For mission planners, the challenge will be squeezing in the observations. Both Mars Express and ExoMars already have packed schedules, focused on their Martian science goals. But the scientific payoff of turning their gaze outward, even briefly, is enormous. This is only the third interstellar object humanity has ever seen, and the first to come within observational reach of active spacecraft. Passing up the opportunity is unthinkable. The data collected in October may not answer all the questions about Atlas, but it could give us the clearest look yet at the strange chemistry and structure of this object, helping confirm or challenge the puzzling findings of Earth-based observatories. And beyond that, it is a reminder of how fortunate we are. Interstellar visitors are vanishingly rare, yet here we are, with spacecraft already in place to meet one as it sweeps past a neighboring world. It is moments like this that make planetary science feel like detective work. We may not know what Atlas truly is, but every new perspective, every new observation brings us closer to solving the mystery. And the upcoming Mars flyby could be one of the most important chapters in that search. While the October flyby of Mars promises exciting close-up observations, 3I Atlas's journey doesn't end there. In fact, the object will continue its rapid trek out of the inner solar system, and the next major opportunity to study it comes in March 2026. On March 16, 2026, Atlas will pass within 53 million kilometers of Jupiter, bringing it close enough for one of our existing spacecraft in the Jovian system to potentially get a glimpse. That spacecraft is NASA's Juno probe, which has been orbiting Jupiter since 2016. Originally launched to study the gas giant's atmosphere, magnetosphere, and internal structure, Juno has exceeded expectations in both longevity and scientific output. However, its main mission was scheduled to conclude in September 2025, with plans to deorbit the probe into Jupiter's atmosphere to avoid contaminating the planet's moon. Now, Atlas presents a tantalizing alternative. Mission planners could consider extending Juno's life slightly, redirecting its instruments to observe this interstellar visitor as it passes by the giant planet. Even at 53 million kilometers away, Juno could provide unprecedented data, high-resolution imagery of the coma, measurements of its composition, and detailed tracking of its trajectory. For the first time, we might observe an interstellar object with a spacecraft actually within the solar system, rather than relying solely on telescopes from Earth or Mars orbit. The potential scientific payoff is enormous. Observing Atlas from Juno could help refine estimates of the nucleus size, analyze the behavior of its CO2-rich coma, and even offer insight into the peculiar nickel signature detected back on Earth. It may also help confirm or refute some of the more speculative theories, showing whether the sunward tail or unusual emissions have natural explanations or something more mysterious. Of course, extending Juno's mission is not without risk. The spacecraft is aging, and fuel and instrument limitations are serious considerations. But scientists are weighing the opportunity against the once-in-a-lifetime nature of this encounter. interstellar objects are incredibly rare. The chance to observe one from a spacecraft already in place in the outer solar system is almost unprecedented. Beyond the science, there is a sense of wonder and urgency. Atlas is a traveler from another star system, moving so fast that every opportunity to study it must be seized. By the time it passes Jupiter, it will be on its way out of the solar system, never to return. If Juno or any other probe can capture even a few images or measurements, it will add critical pieces to the puzzle of what this alien object really is. In that sense, the March 2026 Jupiter encounter is more than just a waypoint. It is a chance to push the boundaries of our knowledge, to study an interstellar visitor with tools humans have already sent far across space, and to witness in real time the fleeting passage of something both alien and magnificent. Atlas is reminding us that the universe is vast, mysterious, and sometimes, just for a brief moment, it comes close enough to say hello. Atlas has already challenged everything we thought we knew about comets and interstellar objects. From its early brightness beyond Jupiter, its sunward-pointing tail, the massive carbon dioxide coma, and the unusual nickel without iron, to the tantalizing possibilities of alien origins, it has kept astronomers and enthusiasts alike on the edge of their seats. Yet, despite all the observations, so many questions remain unanswered. What exactly is at the heart of Atlas? How did it form? And in what kind of star system? Could there be natural explanations for its strange chemistry and behavior? Or is there something more extraordinary at play? The opportunities to study it, from the upcoming Mars flyby to the potential Juno encounter at Jupiter, offer humanity a fleeting chance to uncover these secrets. But no matter what we learn, Atlas reminds us of the vastness of our galaxy and how little we truly understand about the objects traveling through it. In the end, 3I Atlas is more than just a comet, a chunk of ice, or an interstellar wanderer. It is a messenger from afar, carrying clues about distant worlds and alien systems, and a reminder that the universe is stranger, more complex, and more fascinating than we could have imagined. As it continues on its journey out of our solar system, one thing is certain: the story of 3I Atlas is far from over. And as we follow it across the stars, we are witnessing a rare and extraordinary encounter with the unknown. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.